Where are my juniors? Raise your hand if you're a junior, class of 26. All right, you're all taking your SAT on March 6th. So we're doing, this is a SAT question I got from the website. So let's take a moment and figure out, what do you think our answer would be? How would we approach this if this was on our SAT that we're taking in a couple weeks? So we just need to figure out, what is this mystery number that would make this sentence true? So take a couple minutes and think about it, see if we can figure it out. What do we think it would be? Will we choose A, B, C, or D? So I'm gonna give you all a second, and then we'll do a poll. All right, raise your hand if you would pick A. B, C, D. All right, for those who answered, you are correct. The answer is A. So now let's work through it. First thing we would do is subtract the 8. So P plus 3 equals 2. And then we would subtract 3. 2 minus 3 is -1. Good job, y'all. All right, so make sure for your bell work packet that you write your name. Usually I like to collect these at the end of the semester. I used to collect them at the end of every test, but I think I'm just going to collect them all at the end. So make sure you have your first and last name on your bell work, and then your class period. And now let's go to our pink packet, which is your notes for this module. Include your first and last name, class period, and you can also write that your test, that this is at the bottom of your notes, is Thursday, March 13th. So that's when we're going to take our next test. Wait, is it not the 14th? It's the 13th, you're right. Thursday, March 13th. Thank you. That's our test. Thursday, March 13th. That is our next test. Okay, so Module 5 was all about exponentials, and everything in math has an opposite. So if I were to ask you, what's the opposite of addition, what would you say? Subtraction. If I ask you, what's the opposite of division, what would you say? Multiplication. So the opposite of an exponential is actually a log. These are opposites. They're opposites. Okay, so the first thing we're going to talk about is how to write something written in exponential form in logarithmic form. So you have the base, the exponent, and then A is your argument. I like to say answer too. When we're going backwards, we start off by writing the word log, and then we put our base. The answer comes next, and it's always equal to the exponent. So this rule is going to help you a lot as we work through rewriting and evaluating logs. All right, so let's go ahead and do it. Let's look at these examples and how it was rewritten, and then we will practice rewriting it on our own. So we have a base 2. Notice that that's the same number right there. Let me go ahead and zoom in. See how those numbers are the same? All right, so we have a log base 2. Whatever your base is, that's the number closest to log, okay? And then we have our exponent. When we write it in exponential form, that's what it equals. And then whatever your answer is, or your argument, that's right next to the log. So if we have 2 to the power of 5 equals 32, it would be written as the log base 2 of 32 equals 5. If I have 5 to the power of 3 equals 125, that can be rewritten as the log base 5 of the answer equals my exponent. And then if you have 3 to the power of negative 2 equals 1 over 9, that can be written as the log with the base 3 of 1 over 9 equals negative 2. So now let's go ahead and practice doing some rewriting on our own. Okay? So let's look at this next example and let's do our own rewriting. So we have 4 to the power of 2 equals 16. First thing first, whatever number is your base, that's always the number closest to the log. So do you see how this little bitty 4 is already there? That's where that would go. Then comes your answer. So your answer, that's what goes here. So my answer is 16, so I'm going to put a 16 here. And it equals my exponent, which is 2. So if you have 4 to the power of 2 equals 16, that can be written as log base 4 of 16 equals 2. For question number 2, it says 6 to the power of 0 equals 1. All right, what do you think the number is that I'm going to put in this box closest to the log? 6. Then it's my answer. So what answer did I get? 1. And it equals the exponent. And what was the exponent? 0. Okay, y'all catching on fast. All right, let's do this last one. First, you need to write the word log. The number closest to the log is the base. What's the base? 9. Then it's the answer, which is 1/9, and it equals your exponent. All right, where we at? Thumbs up, sideways, down. We've only done 3. I don't expect us to be experts, but are we following along? Any questions? Shake your head up and down, side to side. I need to see what's going on. All right, so now let's go the other direction. So now it's written as a log, and we need to write it as an exponent. So again, we start with the base, 4. And now if I'm writing an exponent, I go across the equal sign. So that 3 would be my exponent. It equals 64. So log base 4 of 64 equals 3 is the same thing as 4 to the 3rd equals 64. Anybody want to take a guess how you would rewrite question 2? Hajar. Yeah, they wrote this one. So what would be in the first box? So we start off with the base of the log.
I think 1.
Oh, you're on the left. You're on this one. Wait.
Yeah, it's with this one, right?
This one, yeah. So look in here. What would be the base?
64.
The base is the little bitty number right here. This is the base.
Oh, 8.
8, good. Then you go across the equal sign to get your exponent.
2.
-2, good. And it equals, and then right next to the log is your argument.
160.
Good. All right, let's look at question number 3. Somebody besides Juan, because he is participating a lot, which I appreciate. I need some more people to help me out here. Anybody want to volunteer to do number 3? How would you rewrite that in exponential form? Isaiah.
7 to the first
Perfect. Thumbs up, sideways down. Who had that? Any questions? All right, well, let's start graphing. That's my favorite thing to do in math is graph. Anybody else like graphing? Yes, you do. You just don't want to admit it. Okay, so yesterday on the test, we had to graph an exponential. So for old time's sake, let's just do it again. So let's graph this function here. And I still have the table on the chalkboard. I haven't erased it. So let's just go ahead and just graph our good old friend. That we had to graph yesterday on our test. So let's take a minute and graph that. Now, in order to graph a log, we will still create the exponential table, but we're not going to graph it. The reason why is because we need the exponential table to create our log table. So now to graph this function here, which is the log base 2 of x, we need to switch the x and y column. So I'm going to graph this one in blue. So what I'm going to do is I want you to take all of these numbers that you see I have highlighted in yellow. I want you to write those under y. Because when we do our log, x and y, they switch places. So the x values become our y values. So let's go ahead and write those numbers under y. So we have negative 1, 0, 1, 2, 3. And then we're going to take all of our y values and write them under x. So we would have 0.5, 1, 2, 4, 8. Now I want you to graph our log table. Now when you graph a log, it should look like a lowercase r. Like this is what it should look like. It's going to look like that. So let's take a minute and graph that. Now keep in mind though, remember how you see how this exponential graph, it didn't cross the x-axis? What do you think this log is going to do? Instead of not touching the x-axis, it's not going to touch what? What's the opposite of the x-axis? The y-axis. Everything about the log is opposite from an exponential. Everything switches. They're sisters. They're opposite sisters. And that is what your graph is going to look like, kids. So I took all of these numbers and I wrote them here. Oh yeah, I never do the fraction.
Oh, you never do the first one?
No, fraction. So I just did 1, 0, 2, 1, 4, 2, and 8, 3. That's good enough. We don't want to do the fraction. That's too much. All right. Any questions? Well, let's go to the next page, y'all. We're going to skip over that last one. We don't need to do that. Now that we have our introduction, now let's get to the fun part which is transformation. See, I got the transformer up there. So, AH and K is back. AH and K never goes away, ever. Okay? Now, A is going to be in front of the log. H is inside of the parentheses. H is still opposite, though. This is still going to be opposite. K is in the back. Okay? So remember for the test you took yesterday, if it was exponential, you had a domain of all real numbers. Now it's going to be the range that's all real numbers because it flips flops. Does anybody know what the opposite of horizontal would be? Vertical, yeah. So instead of having a horizontal asymptote, now we're going to have a vertical asymptote. And for exponential, K was the MVP, but now it's H's turn to shine. H is the MVP because H is going to determine your domain and where your vertical asymptote is. All right, so let's go ahead and graph. Now, the first thing you want to do is figure out what is that little bitty number next to log. So does everybody see that little bitty baby number? What's that little bitty baby number? 2. So I want you to off to the left. I know you don't have a lot of space. We're going to make our table for 2 to the power of x. We're not going to graph the table, y'all, but we are going to make our table. So let's go ahead. And I have done this so many times that it goes so fast. Now, we're not going to graph it, though. We don't need to graph it. So then we're going to take and do the parent. So when you graph the parent, remember, you switch x and y. So I want you to take all of these numbers and I want you to write them here. And then I want you to take all of these numbers and I want you to write them under x and then graph it again. So we're graphing exactly what you just finished graphing on the last page. We're going to graph it again. So let's go ahead and graph it. You're trying to go to sleep, aren't you? That's why I'm sitting here. You can't do it. We friends. Let's go ahead and graph it. So we got 1 0, 2 1, 4 2, 8 3. And you'll get really fast at making this graph because 90% of the logs we're going to graph will be a base 2. So that's the parent. All right, so now let's practice finding A, H, and K. Let me zoom in on the star. A is the number in front, which in this case is a 1. The number in front of log, if you don't see a number, that means it's 1. H is inside the parentheses, but you flip the sign. So what do you think H is going to be? 2. Is it going to go, what is that going to make our graph do? Right.
But, oh yeah, like you see that you put on the other part.
Exactly, yeah. And then K would be what? 4, and what's that going to make our graph do? 4. The other thing about AH and K that never changes is that it's always going to be H plus X and then Y times A plus K. So I want you to pick up your calculator. You're adding 2 to all of these numbers. And for your Y values, you're multiplying it by 1 and adding 4. But hold on, let's hold up for a second. Before we do that, let's fill in some information before we start. I got a little bit ahead of myself. Let's fill in some of this information. Now remember, now it's the H's turn to shine. So this H value is going to tell you your domain and your vertical asymptote. So your domain is X is greater than 2. And your vertical asymptote is going to be at X equals 2. So I'm going to actually draw that in. I'm going to draw in a dashed line. I want everybody to do that. At X equals 2, I want you to draw in this. It's like a wall. A vertical asymptote is a wall that the graph cannot go through. All right, so go ahead, pick up your calculators and get your new table. So I want you to take all of these numbers, you're going to add 2. And all of these numbers, you're really just adding 4 because, multiplying by 1 doesn't change anything. So take all of your X values and add 2. All of your Y values, add 4. All right. Can you check my table? Did you all get the same thing I got? So I'm doing some mental math. We got that? You got that? Those numbers? Okay. All right, let's go ahead and graph it out. Again, I just put the decimal there, but for me, it's kind of hard because it's not that precise. Okay, so 3 up 4. So 3 up 4, put a point. 4 up 5, put a point. 6 up 6, put a point. And 10 up 7, put a point. And again, it's going to come through. You can't go through the wall. So it just goes straight down. And that is your graph. All right, one more question and then we're done for today. We're going to start working on that homework because I'm giving extra credit for it tomorrow. All right, so we're going to start off by what's the little bitty baby number next to the log? What's the little bitty baby number you see? A 3. So I'm going to do this at the bottom. I know you have some space. Let's make our table for y equals 3 to the x. Now, again, I'm not graphing the table. I'm just making it so it can help me create my log table. So I'm going to help you really quickly. If you type that in your calculator, those are your y values.
It's not the same as for 2, 1.
No, because now the little bitty baby number is a 3. Can you answer for me?
Can you move so I can see the graph like?
Yeah, sorry. I was doing everything. But right here, this little bitty number here, 3, that's your base. So because the base is 3, now we're going to start with y equals 3 to the power of x. All right, so that's our table. So now let's go ahead and flip that table. So take all of these numbers and write them under y. Take all of these numbers and write them under x. And then graph it. So again, we're making a table, but we're not graphing exponentials. We just make the table to help us create our log graph. So let's go ahead and do that. You okay, Daniela? You okay? Okay. All right, so I'm going to put those numbers here. We got 0.3, 139, 210, -1. Let's go ahead and graph that, y'all. So it comes through, comes through, and then it goes straight down, just like that. So that's our parent. So what's my h value? H is inside of the parentheses, flip the sign. -4, which is going to make it go left 4. So because that's the MVP, I like to fill in the rest. That means that my domain is going to be x is greater than -4. And this time my wall is going to be at x equals -4.
But you don't find it for K and A.
Let me go back. I skipped that part. Because H is the MVP, I filled in everything for H. What would A be? I didn't write it, but what is A? What's the number in front of log? 1. Okay, and then what is our K value? Gabe, what's K? And what's that going to make our graph to? Down 5. Now remember, for a log, your domain, this is never going to be different, y'all. It's all real numbers. So let's go ahead. I want you to add your H, multiply Y times A, and add K. So you're adding -4, and you're multiplying it by 1 and subtracting 5. So take a minute and get your new table, graph it out, and we'll be done. Now, I like to draw in the wall. So I'm going to draw in my little dashed x equals -4. Actually, I'm going to do it in yellow. Oops. That didn't go the way I thought it would. Okay, I'm going to do this in yellow. So this is where the wall is for this next one. It's not going to go through the wall. We can't walk through a wall. So you're going to add the -4 and then subtract the 5. So go ahead and do that and graph it. I do not remember getting these numbers first period, so check and make sure that's right. I think it's right. Thumbs up if you got the same numbers I got. Okay. All right, so let's go ahead and graph it. -3 down 5. -1 down 4. And 5 down 3. Again, it's gonna come in, hit those 2 points, and then go straight down. And that's how you graph a log, children. It's easy, huh? Kinda, you know. Logs are kind of like, The main thing to keep in mind is that you're creating this table, but we don't graph it. That was for module 5. We don't need to graph it. We flip it and then we graph it. All right, so let's move on to the homework, y'all. Let's take out homework 1. First thing is, can you write that the homework is due on Monday? Monday, your homework is due. Monday, February 24th. Now, we're going to use this time, though, to get most of it done, though. So, Monday, February 24th. So, let's start working on it together. So, let's do the first one. If I had to rewrite number 1 in exponential form, what's the base of my log? 15. You go across the exponent. Across the equal sign. This is your exponent. So if you were to write it, think about it. This is the base. This is your answer. This is your exponent. It's B-A-E. Bay. So to write it in exponential form, Sean, it would be 15 to the power of 2 equals 225. All right, you can finish that row. Now let's go to this one. To go backwards, this is still the base. Now you have your exponent, and this is your answer. So it would be log, write the word log. The base is 2. Next comes the answer, and it equals the exponent. That's how you do that row. So you can finish that row real quick. For now, we're going to skip this row. We'll talk about that row tomorrow. But what you can do is you can fill these in. So y equals 2 to the x. Go ahead and graph it. And then you flip it and graph the log. All of these numbers go here. All of these numbers go here. And we already did this exact same thing on page 2. And then on the back, you have to do log base 3. So on the back, that's y equals 3 to the power of x. So I'm going to help you all with that too. So we only use 4 numbers because we don't have enough space. Now do the same thing. Flip it.
I think that would be good.
What's on the next page? Whatever, back. Which one's it? Yeah, it's log base 3x. Yep, so log base 3 of x. So you're going to write the table for the exponential, and then you're going to do the same thing for the log. All right, y'all. So if you all finish all of those questions that we started, tomorrow's class is short. You'll be able to finish the whole homework and turn it in tomorrow. And guess what you get if you turn it in tomorrow? Extra credit. So let's use this time to get done the questions that I helped you get started on.